Alright. Alright guys, so what I wanted to do today, I just wanted to record a little video. And what I'm trying to demonstrate here is sort of how to wrap your head around a problem and work through the steps logically to understanding how we would get to the desired result. Like, what are we trying to build? What is the functionality that we're looking for? And how do we get there? And being able to translate those skills over to code. Because maybe logically we know that we can solve this problem in our head, we can solve this problem logically, we know the steps, we know how to do it, but how do we take that knowledge and translate it to computer instructions, right? And so that's what this video is kind of about. And so what I wanted to do is just work out this problem. I want to solve a linear equation. Not super complicated, but we are working with algebra, we're working with math, so it's kind of to give you an idea that we can solve some algebraic issues with code because code inherently follows algebraic principles. A formula in algebra can also be called a function. Something comes in and something comes out. There is an input and some operations are done to that input and then the output comes out, right? So what I want to do is write a function that takes in at least two coordinates off of a graph. And with those two coordinates, it can calculate the slope of the graph, and then it can find the y value at any given x. So this is the most important part of what you will be learning today, which is how to pseudocode and how to go from understanding a problem to understanding the code and how to write the code, right? So stepping through the logic in your brain, what makes sense to you? So the first step in pseudocode, always, what do you want? What are we trying to build here? What is the desired functionality? In this case, my desired functionality is I want to write a function that takes in two coordinates from a graph and uses those coordinates to perform calculations, and it will return the x value, the y value at any given x coordinate on that graph. So, given a data set that has two coordinates at least, and the x value that we're trying to solve y for. So then we want to break down, after you understand what are you building, what is the input. That's what this given means, is input. What comes into the function, and you can think about functions kind of like a conveyor belt, right? Or a factory line, right? Something comes down the line, and it's moving down this conveyor belt, and then eventually it's moving down the conveyor belt and it enters the function. Function is essentially the order of operations. What operations are we going to do? What order are we going to do them in? And what are we trying to get out of it? And then, so inside of our function, we have to take in our input and we have to do things to it so that we get our desired output. And that's fundamental to understanding this analysis, right? So our input is a data set, two coordinates, and a desired x. And then the function. So the first thing we need to understand is the input. Then we need to understand the function. So what operations are we going to do inside of the black box that is the function? What operations are we going to do? What order do we need to do them in? And then what is the desired output? What are we trying to spit back out. So, the input, 2 coordinates, desired x. How do we go from that input to finding y for a given x coordinate? Well, we would want to grab 2 coordinates because to calculate the slope, we will need 2 points on the graph. Then, once we calculate the slope, we can use the slope to find the y-intercept. Once we have the y-intercept, we have the entire equation. You may remember this from beginner algebra, y equals mx plus b. Well, our desired output is y. And one of our inputs is the desired x. So we have x, we're trying to return y. So what do we need? We need the slope, and we need the y-intercept. So the first thing we want to do is calculate the slope because we need the slope to be able to find the y-intercept. But then it's just this equation. It's just a matter of getting the relevant information, the slope and the y-intercept, and then applying all of those things and spitting out the result of that equation. So this is what our data is going to look like. It's going to be an array. And an array can hold any type of data inside of it, and it doesn't always have to be the same type. So inside of an array, you could have strings, integers, Boolean, true or false, null, any value, any data type that is defined in JavaScript you can have inside of an array. Well, what we're going to do is we're going to have an array, and we'll call this the super array. And the super array is going to house a couple subarrays. And the subarrays you can think of as coordinates, right? This would be like 1 on the x-axis and 5 on the y-axis. And so if we return to that image of the graph really quickly, this would be portrayed as 1, 5. So it would be this point right here on the graph. And then there'd be 2, 2 on the horizontal axis, and then 10, right? So this is a 2-dimensional array. It's an array that houses smaller arrays, or it's a list of sublists, right? And so here's what we're going to do, actually. The first step, and I'm just going to have to back up through that explanation there, those comments. So we're writing a function, solve for y at x. And we know that we want to pass in our data set, and we want our desired x value. So here I've created the function, and I'm calling the function inside of here, passing in our 2-dimensional array of data and the desired x value that we want to solve for. All right. So that's going to be our parameters. You could call this data, you could call it data set, you could call it array, you could call it anything you want. This is a generic variable name, but as long as you understand that when we're writing a function, we use the function keyword, we give it a name, and then within the parentheses, we define the input. What's coming into this function? Well, it's going to be the coordinate array, and it's going to be the x value we're trying to solve for. And that's why here we want to understand the given. What is the input? Because whatever the input is, whatever we need to have provided to us to solve this is going to have to come into the function this way. So what are the next steps, right? Well, we've created a function that takes in a set of data and a desired coordinate. How do we make those steps, right? And this is the point. Once you get to this stage where you've created your function, but you're not quite sure what to do with it. You understand it's taking in something, and you understand what you want to get out of it, and maybe you understand how you would get there. But this is the point of the pseudocode. After you've gotten to this point where you have a function, you know what's coming in, and you kind of know what you need to get out, but you don't know the in-between, right? break it down into the smallest possible steps, right? So here I'm saying I want to grab 2 coordinates from our data set, because potentially this data set could actually have hundreds or thousands of coordinates, and we just need to grab 2 of them, right? And then we want to calculate the slope. We need 2 coordinates to calculate the slope, because otherwise 1 coordinate is just a single point on the graph, and we need to understand the change of the graph vertically and horizontally, right? So let's do that. What I'm going to do is, also, data set with at least 2 coordinates, right? Always act as if you're blind when you're writing a function and you have no idea what could come in here. This is kind of a little bit of a safety check. I'm saying only do this operation if the data set we got is a list that has a length, and if the length of that list is longer than 2. So this was just a little type safety check that I've done. The double and sign means that we will only execute the code inside of this if statement if the left side of the and sign and the right side are both true. It means if this is true and this is true. But if one of these is false, then it'll just skip out of all of that and it won't do anything inside of this block. But I'm just going to go ahead and, for sake of simplicity, I will erase that. But it's good to keep in mind, we don't know that an array is always going to be passed in. We don't know if a two-dimensional array is always going to be passed in, right? So we have to write these checks in, right? First thing we want to do, grab 2 coordinates, calculate the slope, right? Well, I've just created a helper function here called solveSlope. It has 2 parameters, 2 inputs, coordinate 1, coordinate 2. And it uses those to find the delta, or the change in the y-axis, and the change in the x-axis. And then it returns the slope, which is the change in y divided by the change in x. So with this helper function, I could just call this function right here, right? solveSlope, calling that function. And I'm taking our data set here, and I'm grabbing the first coordinate, or the 0th index, and I'm grabbing the second coordinate that was passed into that data set. And it's going to call this solveSlope method. It's going to take these inputs, and it's going to return this output. And we're going to assign the output of this function to a variable called m, as in m for mx plus b, slope times x plus the intercept, right? So this is our slope. Whatever is returned from this function, we're assigning to the variable m. And what are we going to do after we find that, right? Well, we have the slope. Now we have to use that slope to find the y-intercept. So what we can do is grab some temporary x and y coordinates, and what I'm actually going to do is just grab the first coordinate that was provided in the list, and I'm going to grab the x and the y of that coordinate. So temp x is the first coordinate in the list of coordinates, and it's going to be the first number in that coordinate. That's just how we notate. With graphing, first item is x, second item is y, right? So, doing that with temp x, doing that with temp y, grabbing the x and y values of this first coordinate here, and then I'm trying to solve for b, the y-intercept. So I'm taking this temporary y coordinate, right, and I'm just performing this operation on it. Now that we've found the slope, and the slope is the ratio of change between x and change between y. So let's say in this case that temp x is 10, right? Well, we need to make 10 steps backwards to get to 0, right? If we pull up the graph again, let's say we're at 10. We need to make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps backwards to get to 0. And the y-intercept is wherever x equals 0. So this is essentially saying however many steps away from center we need to take those backward steps. So if we're 10 steps to the right of the center, we need to take 10 steps to the left to get back to center. Or if we're -10, we're 10 steps to the left, we need to be 10 steps to the right. And so for every time we make a step in the x direction, we need to make the proportional step in the y direction, and that's what the slope is for. So for every time, let's pretend that our slope is 3. That's not the case in this data set, but let's say it was. For every time we step to the right on the x-axis, we need to step upwards and on the y-axis 3 times. So if x is 10 and y is 10, then where x is 11, y would be 13. So this is the ratio of y change to every 1 change in x. So what we're saying is, how many steps do we need to make to find x equals 0? And how much change in the y value are we going to see? And then we're going to take this. This is essentially the change in y value from whatever x coordinate to 0. And that's how we find the y-intercept. And visually, if you're a visual person, I know I am, the way we can think about that is if we had absolutely no knowledge of where 0 is on the graph and we were only given this. Oops. There. So if we were only provided this much information, well, we only got a couple points or a couple things we can take a look at here, right? And if we kept zooming in, then our field of reference gets even lower. But what we do know is that this would be -10 on the x-axis and -10 on the y-axis. This would be -9 and -9. So you can imagine it to be how much change in y are we going to see to get from -10 on the x to 0 on the x, right? And so like we can see from -10 to -5, there's 5. We're increasing x by 5, and look, over that time, we're increasing y by 5. Now, this isn't always going to be the case. This is just the case if your slope is 1, if y and x are always equal to each other. But that's just the way you can think about it. How do we step from this coordinate to 0? And what do we do from there? Well, now that we've got the slope, we've got the y-intercept, we just need to solve for our output, right? And our output, remember, we're looking for y. And our formula is to get y, we need the slope times the desired x plus b. So all that's left is our output. And a function's output is always going to be the return value. The return value is the output. When we call this function, it's going to evaluate this function to whatever this turns out to be. And so let's just run this and see what we've got. So 25. That might not mean a whole lot to you, but let's take a look. We've got our first coordinate of 1 on the x-axis, 5 on the y-axis. And then we've got 2 and 10. So you might think for every 1 step we make in the x direction, we make 5 steps in the y vertical direction. And we're trying to solve for x equals 5. So we're saying when x equals 5, y will be 25. So that was quite easy. All we had to do was pass in a data set, and no matter how we change this data set, this function will still work so long as the data set is consistent, so long as the coordinates are linear. If my next coordinate